So this problem, we're looking at the different probabilities of moving up in a grade on a paper that you've written. So as we know, once you get a certain grade, you can no longer move down a step. So we have here that E1 is going to be you get an A or a B, E2 is getting a C or a D, and E3 is failing that paper. So we know that once you get an A on this paper, you can no longer get anything more. Sorry, once you get an A or a B, you're in that forever. So we have 1, 0, 0, because once you have the probability of staying in that state is 1. You know, once you're there for good. If you get a B or a C or a D on a paper, on one of the drafts, then you have a 0.7 probability of on your next draft getting an A on that paper or a B. And if you get a C or a D, there's a 0.3 probability that you'll stay getting a C or a D on the next draft. And finally, if you start out failing that paper, you'll end up with a 10% chance of moving to an A from an F. You have a 60% chance of getting a C or a D on the next draft, and you have a 30% chance of still failing on that next draft. And so what this tells us is that E1 is an absorbing state. So we'll write that E1 absorbs. So that's all we need to do for part A, is we set up our probability matrix, and we know that E1 is our absorbing state. So now part B asks us to subdivide that matrix. And so this is really nice because our absorbing state is already in the first row in the first column. So all we do is divide it so that we have our 1 in the first row in the first column, because that's our identity matrix here. We have a 0 matrix here on the right of that. This is our matrix S, and this is our matrix Q. So that's all we have to do for part B, is as you see we have it subdivided so that we have our 4 different parts of our matrix. Now in part C, what we need to do is find the expected number of trials of being absorbed before you'd be absorbed into E1. So that's the expected amount of drafts you would have to do before you'd expect to get an A, depending on what grade you got first. So to do that, we need to find our matrix T. And T equals I minus Q inverse. So I is our identity matrix, and Q is this matrix here. So what we're going to do is take 1, 0, 0, 1, because we have a 2 by 2 matrix, and subtract that from our matrix Q. And then find the inverse. So let's go over here and write that T equals the inverse of 0.7, 0, negative 0.6, and 0.7, and again, we're still finding the inverse of that. And so this is where you would either use a calculator or you could use the solutions where we put the identity matrix on the right and then solve and get this to the identity matrix. However you want to solve for the inverse, but you should end up getting that the final answer is, and I have it written down, 10 over 7, 0, 60 over 49, and 10 over 7. And so that is our matrix T. And so now, to solve for the probabilities or the amount of trials that it's going to take to get us into the absorbing state, we're going to add the rows. So this is going to correspond to E2, and this is E3. So this is starting at E2, and this is starting at E3. So we have E2 is going to be 10 over 7, which is roughly 1.4, which tells us that we're expecting to take 2 trials to get an A on that paper. So if you start by getting a C or a D on your first draft, you would take most likely 2 trials to get an A on that paper. And now if we take E3, we're going to take 60 over 49 plus, we'll call this 70 over 49 just to get our common denominator. And that is 130 over 49, which is between 2 and 3, which tells us that we'd have to take 3 trials before we get from a C, or before we get from a failing grade to an A. And so that's all we have to do for part C. And now finally, for part D, we want to know the probability that you would end up getting an A given that you started out by getting an F. And so to do that, we're going to take matrix T, which we found over there, times matrix S. And so T times S will then tell us the probability of starting in one state and getting to the absorbing state. And so this will actually tell us the probability of you starting out getting a C or a D and getting to an A, or getting an F and getting to an A. So to do that, we take our matrix T, so 10 over 7, 0, 60 over 49, and 10 over 7. And we're going to multiply that by our matrix S, which was over there. And again, it is this matrix right here. So that is a 2 by 1 matrix, which we know we can multiply by a 2 by 2 matrix because the two middle numbers are the same. So we're going to take this as 7 over 10 and 1 over 10. And again, I'm not going to go through the multiplication here, but you should end up getting that this equals 1, 1. So you're going to end up with a 2 by 1 matrix. That's 1, 1. So what does that tell us? That means that regardless of what state you start in, so even if you get an F on the first drift, or if you get a C or a D, there's still a probability of 1 that we get to an A. So that means that regardless of what your first paper is, you should end up getting an A. And that's all we need for part D.